Alrighty, first section of Unit 2. We're talking about quadratic functions in Unit 2. If you're in Algebra 2, I'll probably refer to it as 2.2a because we're technically skipping section 2.1. For Honors Algebra 2, I put it as 2.1. It's the same thing either way. So we're talking about properties of quadratic function. First of all, in standard form, we're going to talk about more properties later. So here's a warm-up that I want us to take a look at. So it says give the coordinates of the vertex of the function g of x equals x minus 4 squared minus 2. Now, some of your notes are going to have the vertex form already given there, but some of them don't. Let's see if we can figure this out, how to do it without knowing what the vertex form even looks like. So the parent function on this one is f of x equals x squared. The vertex of a function is kind of like, or of a graph is where it bottoms out or it reaches the top. Now, typically, the bottom part of the x squared graph would be at the coordinate 0, 0. So using what we know about transformations, let's see if we can think about what happened to the vertex when it looks like x minus 4 squared minus 2. The minus 4 is a shift to the right by 4. The minus 2 here, I'm going to zoom in a little bit. The minus 2 here is a shift down by 2. So if we take the coordinates, I'm going to just do x and y here. If we do the coordinates x and y from f of x equals x squared, and we transform them, shifting right 4 would be x plus 4, because remember, it's kind of the opposite of what's going on in the function. And then the y value would be y minus 2. That one's more straightforward. So in other words, the vertex for this one, we're going to add 4 to the 0, so we get 4, and then we're going to subtract 2 from the y coordinate, and get negative 2. So we have the vertex at 4, negative 2. Now we're also asked to graph the, oops, sorry, I'm not on the screen there. We're also asked to graph the function for part 1. And let's take a look at what happens at the line x equals 4. So what I'm going to have us do is, well, we know where that vertex is. It's at positive 4. So let's choose some points around that. So I'm going to choose 2, 3, 4, 5, and 6. And we'll plug those in and see what we get as our outputs. So we're going to plug into, and I'm just going to kind of verbally go through this, but we're going to plug each of these in for the x up here. So we plug in 2, we subtract 4, we get negative 2. Then we square it, we get back to positive 4, and then we subtract 2, we're at 2. Plugging in 3, we do 3 minus 4, which is negative 1. Square that, we end up with positive 1. Minus 2, we get a coordinate at 3, negative 1. Plugging in 4, we get 4 minus 4, which is 0. Square that, still 0. Minus 2, we're at negative 2. Well, good, that's the vertex point that we had already found. Going on with 5. 5 minus 4 is 1. Square it, we still get 1. Subtract 2, we're at negative 1. 6 minus 4 is 2. Square it is 4. Minus 2 again, we're at 2. So let's plot these. So at 2, 2, so I have a stray mark there. We got point at 2, 2, 3, negative 1. Oops, sorry. 3, negative 1, 4, negative 2, 5, negative 1, and 6, 2. So our parabola looks a little something like this. It's not my best parabola, but it's not the worst. So that's what this graph kind of looks like. Now it also asks us, what do you notice about the line x equals 4? Well, the line x equals 4 is a vertical line that goes up through here. Now that's not perfect. Let me shift it over a little bit. That's better. Notice it goes through the vertex. It also kind of splits the graph in half. We're going to talk more about that in a little bit. So our goal for the day, we're going to define, identify, and graph quadratic functions. And here's the first thing we're going to talk about. As we discovered in the warm-up, every parabola of the form f of x equals a times x minus h squared plus k has an axis of symmetry at, let's go back. Where was it? It was at x equals 4. Where did we get that from this function? It's right in there. So it's x minus 4 is in the function, so that's where our axis of symmetry ends up being. So in the function a of a times x minus h squared plus k, it's going to be at the coordinate x equals, or it's going to be at the line x equals h. My apologies. So it's going to be at the line x equals h. So the proper definition is the axis of symmetry is a vertical line through the vertex of the graph's function, or of the function's graph. So the equation f of x equals a times x minus h squared plus k has an axis of symmetry at x equals h. And you can kind of see that on this graph here. Let me move my picture so I'm not covering it as much. And you should also know that as we go along, we're going to probably refer to the axis of symmetry as AOS. So we're not going to keep using axis of symmetry over and over and over and over. We're going to use just the letters AOS to save time. All right, taking a look at a couple examples here. We're calling this one example 0. We'll talk about example 1 later. The rest to find the axis of symmetry for the functions below. So f of x equals x minus 3 squared plus 1. Well, following along, we're going to have our axis of symmetry is going to be some line x equals, and let's go back to the previous page, x equals h. Notice where h is in here. It's x minus the h value. So it's x minus 3, so it's going to be the axis of symmetry at the line x equals 3. For the next one, take a moment after you read through this. G of x equals x plus 8 squared plus 9,082. Now, I want you to think about that, what the axis of symmetry is going to be. So pause the video and say, tell me what x is equal to. Okay, you clearly paused. So it's going to be x equals negative 8. Now, you might be thinking, wait, there's no negative 8 in there. Sure there is. It's just written kind of differently. X plus 8 is the same as x minus negative 8. If we wanted to match up with the pattern that we have here, where it's a minus h, but then just positive h here, we have to think about kind of the opposite. Again, kind of like what we did with horizontal translations, shifting to the left and to the right, it's kind of the opposite. So in this x plus 8, thinking about it in those transformations, that's a shift left by 8. So that's why we end up at x equals negative 8.